So let me check. I think I'm mic'd up. Yes, okay. So probably the most important thing I want to say in this talk is the bit that I might otherwise have left at the end, but I want to be able to say it now, which is to thank Jed for the inspiration he supplies to anybody who works with him. So I'm one of the editors of Archive for History of Exact Sciences. That's how I've mostly got to know Jed. Otherwise, I try and keep up with his many books and learn from them. So the Maxwell books were a great inspiration to me. And Jed's built a community around Archive for History of Exact Sciences, which I think is tremendously important. And it's my pleasure to stand here and thank Jed for everything he's done, and to thank Diana and everybody else for putting on this splendid event. Gracious. So my theme is on the history of mathematics, and particularly the relationship of history of mathematics to the history of science. So nobody disputes, I think, that mathematics plays an important role in science, and Noel reminds us of the views of Regiomontanus on that. It's much harder to demonstrate the role of history of mathematics in the history of science. It tends to get squeezed out to one side, and you might think this is because the history of science is a huge field. Right? It covers an immense number of centuries, and it covers an immense number of topics, and it's simply unreasonable to ask any historian of science, or any department of in history of science, to cover the whole thing. So there'll be gaps, right? And you might think that history of mathematics is one of those gaps, more or less understandably, but given the relationship of mathematics to science, that can hardly be right. And of course, it has never been the view of Archive. Archive for History of Exact Sciences includes mathematics in its, what we would now horribly call a mission statement. And Truesdale made sure it was there from the start. He relied initially on the elderly mathematicians he knew personally, so we're kind of in the role of historians of chemistry that Trevor was talking about versus chemists. But pretty quickly, he caught on to people like Tom Whiteside, and brought in people like Henk Bos, and there became an involvement of professional historians of mathematics in the pages of Archive. And I think that's been a very important tradition that also Jed has helped to keep alive. I don't find it so much in some of the other journals in the history of science, and I don't find it so much in some of the other departments that we find in England, for example, or in this country. The history of mathematics is fully represented, I would say, to be partisan about it. And I would like to talk a little bit about the implications and the consequences of that, especially for the modern period, because I work largely on the 19th century. And of course, it has to do with things like languages. The mathematics, modern mathematics from the 16th century on is written in several different languages, and you have to have some acquaintance with them to be able to muddle your way through. Although, to be honest, in mathematics, not a lot, right? Many of the technical words are the same in every language, and the sentences are rather simple to understand. So it's a little curious, it seems to me. But I think part of the problem is that mathematics is a body of ideas. It's not just a body of results or techniques. It's also a living body of ideas, and the place of that is very, very hard to grasp. So how has the community set about doing this? Well, it's got various specialist journals. Historia Mathematica was set up in 1974. Revue d'Histoire des Mathématiques, the French journal, comes from 1995. The Science in Context, that is always friendly to mathematics. So things have been coming along, I would say perhaps a generation in some ways after the kind of advent of history of science that Craig has just mentioned. It doesn't go back, I think, to the 1950s. We're still then in the era of the mathematician reminiscing, and I'll say a word or two later about what I think is tricky about that. And then there came along, perhaps more in Europe actually than in this country, a generation of historians of mathematics. Your next speaker, I think, or the next speaker but one, Jesper Lutzen is one of those. I'm one. Various people whose names appear now involved in Archive, for example, came up this way. Some of us were self-taught. We grew up in mathematics departments and drifted into history. Some of us perhaps had a richer connection to the history of science and its official incarnations in various ways. And this is aspect of the problem we have, I think, that you can be a historian of mathematics without having had the deep immersion in the methods of history of science. And so the dialogue between historians of mathematics and historians of science is a little complicated that way. I don't want to say that everybody is in one situation or another, but there are different relationships between the individuals and the profession. But at all events, these people have brought about quite a range of achievements. And I will say a little bit about what has happened in, for example, the 19th century. So in the 19th century, I think it's fair to say that the number of topics, mathematical topics that have been taken up, the relationship that they have to the sciences, or to a certain extent, the philosophical implications for this, have been quite widely developed. There's been an extensive amount of work. There's been a considerable number of biographies of the major mathematicians, a certain amount of attention to the role of institutions in the development of mathematics, a certain amount of attention, for example, to Karen Parshall's work, David Rowe's work on the arrival of modern mathematics in the United States, certain amount of attention in the work, for example, Tom Hawkins, who's one of the leading American historians of mathematics, on the importance of Göttingen in Germany and the building up of the tremendously dominant mathematical department before the Nazi time. And I think most of us who've worked on the 19th century, the long 19th century, were attracted to it because actually it's sort of coherent, right? You could imagine setting off, diving in the middle, moving in either direction, and winding up with a picture of a century, right? There's something happens before, but then you get the French Revolution. There's something happens afterwards, but you have the First World War. So within those brackets, if you like, you have the opportunity to appreciate the development of mathematics and to appreciate the relationship of mathematics, as Craig just indicated very briefly, to the physical sciences, or specifically, I think, to physics. And I should say, and I think perhaps apologize at this stage, that I come from a maths department, so I use the convention of many a mathematics department that statistics lives somewhere else, right? So it's not a division of mathematics, and that's a limitation of this talk. I did once ask a head of a department in a very good mathematics department in England why they'd kept statistics in another department when clearly it didn't make any mathematical sense. And he said, well, if we put statistics into our department and then advertised, we'd get nothing but Russians. So he seemed to think this was sufficient for a small wall of their own. So with that limitation on what I want to say, I think you find in the 19th century the opportunity to immerse yourself in the journals, in the books, and in the mathematics, and to understand it as an evolving system of ideas with connections then to the social aspects of this, the growth of universities rather than academies, for example, all the stuff that you know and probably know better than I do. What hasn't been so successful, despite the example of Truesdell and despite archive, I think, has been work on the history of mathematics in the 18th century. And I think this is partly because the mathematics departments don't recognize the value of it to the extent they recognize the 19th century. You can be a historian of 19th century mathematics and have enough mathematics to teach first and second year undergraduate courses in mathematics. And this gives you an opportunity of a position. It gives your students the opportunities to find jobs. Mathematicians don't look back on the 18th century with the same love. They think it's great fun, but it's, it's pre the rigorous fill in the blank, rigorous calculus, rigorous geometry, rigorous whatever, and they're not quite sure what they want somebody whose mathematics is quite that out of date. But what has happened, and I think it's an innovation that I wholly welcome, and I think it's propitious for future developments, is the Euler Archive. And the Euler Archive is largely run, I think, by American mathematics professors. It offers the opportunity for people to join in the study of Euler and then of related people. But specifically of Euler, a great deal of translating has been done, and I think that's essential. And I think that it offers a community. You could get started on the 18th century through the Euler archive, right, in a way that wasn't available before. And I think it is a model for what we might try and do, or somebody should try and do, also with the very extensive 20th century, to which I shall now turn, because the 20th century is really, for me, the great unknown, okay? So those of us who began in the late 70s, right, might say, well, you know, how far back do you have to go before it's really history rather than, shall we say, sociology? And you might think 50 years. I think there's a television program in England called Antiques Roadshow, and you have to have an object of more than 50 years old to be an antique, right? So I've got company. And the person starting in 1974 might say, well, I'll go back 60 years. That's 1914. Right? Before that, I can be a historian. Right? I will have some chance of real sources, da-di-da-di-da. Well, you can't now. It doesn't make any sense. Right? If you look back 50 or 60 years from now, well, you know, you're in the 1960s maybe. Right? That's an awful lot of the 20th century. If you go back 65, it's 65 years of it, that we have to do as historians. And how we might go about doing that, and since we're invited here to look back and look forward, I think I would like to raise, at least as a question. And you might say, well, look, the subject's very, very difficult. You know, the mathematics is very advanced. This is not the stuff we teach entirely to undergraduates now, all of that stuff. And I don't think anybody can stand here a few hundred yards from the Einstein project and say the mathematics is too hard. That's a feeble excuse. That can't be right. And you couldn't do it if you look at what has been done in the history of quantum mechanics and say, that's easy, but apparently modern algebra isn't. That doesn't make any sense. So I don't think historians can plead that the subject is, you know, so difficult that it really can't be done. But nonetheless, it is, of course, difficult in its own particular way. So what should we do? Well, one answer, I think, is that you could look for propitious questions, good questions about how to proceed. How can we form some kind of umbrella of ideas beneath which we can proceed to more detailed work? So one idea that's been pursued for some time, started with Herbert Mertens, Moritz Epler, myself, is to try and portray the arrival of modern mathematics as simply a modernism. Just the same way that you think Picasso is a modernist, or Le Corbusier is a modernist, or if you want to sing along now, please do, Schoenberg is a modernist. Modern mathematics, okay? It's abstract, it has a very complicated and difficult relationship with the real world, it has its own criteria for value, its own criteria for correctness, its own criteria for what it is that is important to do. And I think that makes it at least a candidate for being a kind of modernism. And this is a way, I think people hope, to connect to other currents in the history of science and, generally speaking, in the history of ideas, that we can present mathematics with all its peculiarities and difficulties, nonetheless, as a familiar kind of intellectual transformation. And of course, its arrival was a huge transformation. Its arrival is the arrival of modern abstract mathematics in all of its glory, and it's the arrival of the connections between mathematics and logic, between mathematics and philosophy, and you find around 1900, plus or minus a few years, this huge debate about the nature of mathematics, the nature of mathematical reasoning, and the connections to philosophy, which, well, I'll say a little more unkindly about right at the end of the talk. There are other aspects of 20th century mathematics that, of course, are going to be difficult. There is suddenly a huge geographical spread in mathematics outside of Europe and America to many, many other places, many unfamiliar archives, many more languages, many more difficult issues. You have also the spread of mathematics into novel topics, into aeronautics, into the subjects of mathematics and war, which have been addressed, and then the complicated relationship between what is sometimes called pure mathematics and applied mathematics. Right? I personally don't think that distinction holds up if you query it at all, but it's sort of there, and you can see it in the names of buildings and departments. I don't think underneath that connection, there's a real connection, and I think it shifts. And I think it's a subject of historical investigation. I think also that since there's a panel tomorrow on no more philosophy than necessary, that there is a connection to philosophy of mathematics, not in its present form, I regret to say. I do not find the deliberations of the structuralists and the formalists and the fictionalists helpful, nor does any mathematician I know. But there is a move, that has been for the last 10 years, to discuss the philosophy of mathematical practice, trying to find out what it is that mathematicians actually do. And they don't leave us a lot of sources. They don't leave us a lot of notebooks. Jesper Lutzen is an expert on Newville's notebooks, but I think he might say that this is an unusually rich collection of notebooks by the standards of most mathematicians. So the attempt to find out from what sources we have, how mathematicians actually proceed before they write that incomprehensible paper, has been a recent development in the philosophy of mathematics because it, again, queries and questions the nature of mathematics. And I think that's the point at which I will, in fact, conclude. I think the history of mathematics involves asking what is mathematics, and there have been times in its history when this question is acute, when it has challenged the mathematicians and the physicists and the philosophers involved. I think one way to think of the history of 20th century mathematics, which mostly remains to be done, is to ask thoroughly and carefully about the nature of mathematical activity in that period. And with those vague remarks, I thank you for listening.